Okay, so in this playlist, I'm gonna explain about probability and statistic. So probability and statistic is essential concept that any data scientist, machine learning engineers needs to understand before uh, they delve into the machine learning fields. So it's also one of the important prerequisites that uh, bes besides linear algebra and also calculus. So why probability is essential? In in a simplest way, I will emphasize that in probability, we will understand how our features and how we can describe our data before we train into our model. So probability helps us to optimize the machine learning performance by managing our data very well. So that's the easiest way to describe the role of probability. So we want to manage the data through probability here, T and statistics. Why? Because using this, uh, we can optimize our machine learning performance, enhance the accuracy, and also the most important thing is to reduce the computational cost of the machine learning model. So essentially, we will get the most efficient machine learning model to solve the particular problem. In addition, as the first is to uh, describe how our data is distributed, and then probability is also helps us to understand why the machine learning itself would predict such uh, accurate prediction. For example, let's say you have this line. Okay, I'm sorry. Let's say you have a distribution of data here. For example, here, simple regression, linear regression. That's what I'm trying to make here. And then you try to train your model and you make this regression, right? And then uh, in machine learning, you might not really understand why, okay, why this linear regression could behave the model, the distribution of data very well here. Why the linear regression here could be exactly located here, why not here, or why not in other place. So you understand more this through probability and statistics. Okay, so there's an underlying theory that helps us to understand this. One of them here is a Gaussian distribution. So basically, it's the way we will learn this later. But the idea is Gaussian distribution helps us to understand there is a distance here. So basically, what this linear regression model does to predict the location of the line here is by measuring the distance between each node that we're gonna predict and our nodes in the line. So we're gonna use this Gaussian distribution to calculate the principle of it. But before we jump into Gaussian principle, then we better understand about what is this, and then what's the distribution of data is, and then uh, another stuff including the terms and also the other nomenclature that might help us to understand this deeper. Okay, so I'm going to start from here to help us. So it doesn't, for this first series probability, so there will be three big parts. where I'm going to explain probability and statistic. But for the first here, my objective is to make you comfortable with all the notations and how can we uh, use each notation to solve problems in statistic and probability. So that's the first objective here. So I think I'm gonna delete this. Since I think you already got the idea about what probability is. So I'm gonna bring you into some introduction related to the notation and how we can really use probability here to apply it in a machine learning application. So how can we express probability in a mathematical way? So let's say you have this circle, okay, and then you have uh, okay, so you have 4, 7, 8, 9, 10. So this is the first example that I want to give you. So let's say we have a box here consists of 10 balls. Okay, uh, you really want black balls that from this box, and then you wonder what is the probability that you can get the black box if you uh, randomly pick uh, during this box in this box. Okay, what is the probability? So the probability of black ball here, so we denote it as ball, is equals to the uh, total of the black ball and then the total of the ball inside of this box. Okay, so as you can see here, the black ball here you have 3, and then the total balls inside is 10. So the easiest way to express this is you have 3.10 the probability, or 0.3, where you will get the desired ball of the black ball from this application, from this from this example. And then another famous example that people use usually uh, to bring probability into a simple way then is using the coin example. So let's say you have a coin, you have two possibilities of getting H, which is head, and also if you flip the other coin, then you have the possibility of getting tail. So if I ask you what is the probability of getting head for each toss of the coin, then uh, each head is 1 divided by total. So the probability of getting head for each toss is 0.5. Okay, so uh, this is the most common example people use to explain probability. Okay, and then what if we toss two coins, for example? What if we toss two coins? Then if we toss two coins, then we want to look at the probability, for example. What is the probability of we will get the same head and head every time we toss two coins? Okay. Uh, so I mean here is when you toss two coins, what is the probability that all heads will appear here? So if you have two coins, then basically this is the first coin. I'm gonna write here, and then this is the first coin. You toss it, then you will get edge, and then you toss it again, then you might get tail. And then for the second coin, this is tail, and then you toss it, you get edge, you toss it, you get tail. The question is, if you want to get edge and head here, then this is 1, meaning the probability that you get hit twice is 1 divided by 1, 2, 3, and 4. So you have 4. So this is the probability of you get hit, double hit when you toss two coins. And then this is the simple concept of probability. And then, but this concept applies in many applications. I'm not going to jump into machine learning, but what I'm trying to explain to you, you get the ideas now. Okay, okay, I'm going to continue to explain probability in other videos. See you.